Okay, so we're going to continue on in our session 2 of module 7. So I'm going to open up our gear project overview here. And so far today, we created our project task list. I have the kind of the original, the brainstorm documentation that Evan created, and it's going to be in the the project task list assignment. And then you can start there and then make it your own by adding the items we talked about that are required there. Now, what we're going to be looking at is going to be the gear design. Okay, I'm just going to do an overview. You guys have done this a couple times for me already, but I'm going to give you an overview of how to get started and then how it's going to lead into your initial gearbox layout. You have to have your shaft or your gear diameters in order to get your center distances and all that kind of stuff. Okay, so so what we're going to do is I am going to, I think how I want to do this. Go back a level quick. And we're going to open up the gearbox gears. This is the assignment where you're going to be handing in what you're going to be doing. But you'll notice here that I kind of just like house this stuff here to be convenient, but we already have our gear specs. Okay, we picked those earlier in this session. But then the criteria PDF is right here. So that's this one. And then you would fill in what your horsepower RPMs are. So we already addressed that, but I have that there for reference. And then the next thing you'll notice here is the Spur Gear Design Excel spreadsheet. So you're going to want to download that. Okay. And then I have our Browning Spur Gear catalog pages. Okay. I printed mine off, but this is the PDF version of it. It's not the entire catalog. So it's not like this, you know, hundreds and hundreds of pages. I just picked out the Spur Gear section with the 20-degree pressure angles that would apply probably to what we're going to be doing. Okay. So I think it's about 16 pages long instead. So, so we'll be kind of looking at this in a bit too, but those are kind of like the main things that you're going to be referencing. Now, as we look here, it's worth looking at the deliverables kind of in the front end here, so you know where you're going with this. So first of all, you're going to do 2 reductions. You're going to do your gear design for the first reduction and the second reduction. Now, I have 5 points arbitrarily on each one of those. Total, this is 20 points. But you're going to run through the spreadsheet and we'll look at that in just a bit. But you'll have 2 spreadsheets that you're going to be doing for me, one for the first reduction, one for the second reduction. Then once you do that, you are going to be able to pick out what you believe your first shot at your gear blanks are going to be. That means you're going to have 4 gears total, 2 for the first and 2 for the second. Now, in some cases, you might be able to use the same 2 on the first one as you did on the second ones, because if you have something like what I had where it was 3-to-1 and 3-to-1, you might be able to use that for both. Okay. So, so if you wanted to do that, that would be 2, but you would need to specify it for both of them. You're going to need your vendor. Now, Browning just seems like it's probably makes sense to do this one. But if you look online, like I said, there's Rush Gears, there's other manufacturers, you know, you just want to tell me what your vendor is, what the part number is that you would order for that gear blank that you chose, what the diametral pitch is, the number of teeth, the pitch diameter, the maximum bore, the bore nominal size. Now, you'll notice that there's an asterisk after this. Please, everybody, if you're clicking, I'm telling you important stuff. Pay attention. So the one that has the single star by it, you won't be able to put your bore nominal size until after shaft design. Okay. But make a place for it or a column for it in your spreadsheet where you're going to be listing these things. And then you're going to have your bore tolerance limits. Okay, is going to be another column. So once you know what the nominal size is or the basic size, then you're going to be specifying the limits, and we'll visit, you know, how we do that. But that's going to be after shaft design because there's a star by it. Then you're also going to have a column for the keyway nominal size, and then the keyway tolerances. And you'll notice with 2 asterisks, that's after key design. But make a space for it because you know you'll be filling it in. Okay, because we won't be completely done with gears until we go to do into those other things, right? Now it says use Excel and make sure you're formatting this again in a professional and easy to read way. What you can do and what I would suggest you do, you'll notice that you have a first reduction here and a second reduction, okay? I would open up that gear spreadsheet, okay? and you have one sheet that everything is done on. And what you can do is you can, at the bottom of the tab, you can say, this is your first reduction. And then you can copy it to the second sheet, and then that's your second reduction. And then you can open up a third tab, a third sheet, and you can call that your, design summary, if you would, and then you can list the items that are here on that third sheet. Does that make sense? Okay. So you could do this all, I believe, in one spreadsheet. Okay. And I encourage you to do that. I think that's, and then that way, as we add things like shaft design, you can continue to build more tabs and copy and paste those elements in as well. So I envision possibly, if it doesn't get too vague, is that once we get to the portfolio level, that it truly could be possibly a single Excel spreadsheet that has all the different tabs. And then that way your project is all in one file, it's all in Excel, and then you just click the tabs to kind of see what you did in each area. That's how I'm kind of envisioning this, okay? If you have other ideas about that, I'm totally open to that, but I think that's one way that could easily kind of keep it all together, all right? So that's what you're gonna be kind of looking to. So let's go back over here to Gears. So any questions about what's gonna be required? All right, it's kind of where we're going with this. So let's look at our spreadsheet and just kind of revisit it. Again, remember, this is going to be overview stuff. I'm not going through the spreadsheet or running any numbers. This is truly just, let's like hit the highlights here and just remind us of the things that we have to be aware of. So I have my spreadsheet open already. Okay. I'm going to kind of get me out of the way here. And at the top of the spreadsheet, you're going to notice that it's, going to kind of ask you the items. So it starts out with power, then it goes to input speed. Now, remember, you need to do one of these spreadsheets for the first reduction and one for the second. Your first reduction input speed is going to be off of the little slip that you got. Okay. Your specifications. The input for your second reduction is going to be the output, the desired, or what your final output is. Where is it? Hold on. The output speed, which will be down here after you calculate and your final number of teeth. You are going to have this as your input for the second reduction, because now this is the same shaft. If we look underneath at our layout, oops, I disconnected. No, sorry, hold on. Let me reopen this. It should be, maybe I did this accidentally. Sometimes if it gets jostled around a little bit, it can do that. I just want to look at. So our input is the 8. In my case, it was the 870. I did a 3-to-1 ratio. So my second is going to be 290. This is the output of the first set, which is on the same shaft as the input or the pinion for the second set. Okay. So that pinion, that input for the second set is going to be the output for the first. Okay. So just keep that in mind. So when you do the second reduction and the second spreadsheet, that's going to be your input RPM. Power remains the same. Power remains the same. Okay. Now, diametral pitch, you're going to notice that, remember, anything in red is going to be the 6th edition. So it's referencing the figures and the pages for that. So if you need to go back and determine, what your diametral pitch is. Eric, we're not guessing diametral pitches. Okay. What you're going to do is you're going to use this figure, this chart, and it's going to guide you as to where you want to start. Okay. I will tell you on that chart, if you go to the next closest one, go 2 more up. I know it's always low. All right. It's always low. So I always advise students to go higher right away, because otherwise you'll go through, your stresses will be high. Why don't I look at it right away? Hold on. So 377, the chart that I'm referring to here. And it's just from experience that I have in doing this. Okay. So I'm going to go underneath. On page 377, it's this figure right here. And what this figure does is it's going to help us to get a starting point for the size of our teeth, which is the diametral pitch. And you're going to use your pinion speed. Okay. Mine was 870, so kind of in here-ish. And then your design horsepower. That's going to be your horsepower multiplied by your your overload factor, okay? If you need some help with that, the process is there in the book. But you're going to go up to where you get your design horsepower and met. And once you land there, you go up to the next line. This is a diametral pitch of 10. What I suggest you start with is not 10. Go up 1, 2, all right, every time. Otherwise, you're going to find that it's going to be, your stresses are going to be too high right away at the bottom. So start with 2 above and see how that goes. It should be better for you by doing that, just to help you save a little bit of time. Okay. Then what it's going to do is it's going to ask you for the number of teeth on your pinion. This is where you're going to be grabbing out your Browning catalog or a catalog of your choice off the internet. And you're going to be looking, okay, what number of teeth do they have? Okay. You're going to find the diametral pitch where you started. And then you're basically going to see what number of teeth they have available. Because remember, they don't have all of them. Like in this case, they go from 12 to 14 to 15 to 16, and then they skip over to 18 and so on. Okay. So that's how you're going to pick the number of teeth based on your diametral pitch, 20-degree pressure angle, and then it also gives you the face width, which you'll need a little bit later down the road. Okay. So the catalog pages that I have here are, a bunch. I think there's like 14 pages. So there's probably like 6, 8 different sizes here that should cover what you're looking for. But if not, let me know and I can always get more, or you can always look on the internet. Now, once you know what your desired speed is coming out, okay, it's then going to predict for you the computed number of teeth. It's probably going to be something that is not an integer number, and it's probably going to be something that is not on your list here to be one of, another gear that you could pick. It has to be off of the list, all right? So what you're going to do then is you're going to choose your number of teeth, and you're going to see where your output speed comes out to be, if it's close enough to what you need yours to be. I did not give you a plus or minus for this problem. You're the designer, okay? Reasonable, all right? It might not be exactly, but reasonable in the end, okay? And then as you know, it's going to calculate all these values for you. Then you're going to put your face within, and then you get to do all of the charts, okay? So you'll notice on the right-hand side here, we have the references to the charts and the page numbers, and then you're going to work all the way down to the bottom, okay? Now, remember, there's a good chance you're probably going to have to put your Y's and your Z's in. Remember, those were bending stress cycle numbers when we exceeded 1 million or 10 million. I think it was 10 million cycles. When we exceeded 10 million cycles, you had to put these in, okay? And that's what, 10 million. That's what this is over here. So once you do that, then your final bending stress numbers are the ones that are listed down here with the little prime on them, okay? They're the adjusted allowables. These are the adjustable allowables that you then take to the through hardened materials for bending and for your contact stress. And then you read, and this is where you'll know, are my stresses too high? If they're too high, you've got to go back up to the top. And the easiest place to start is to just go with a smaller diametral pitch. Remember, the smaller the number, the bigger, the chunkier the teeth are. Okay. So if you were calling out a diametral pitch of 10, for instance, go to an 8. All right. Because that'll give you a bigger, chunkier tooth. And then you'll have a wider face width. Then you're just going to double check these numbers. It won't take as long, I promise. It always goes faster the second time. And you'll see how those stresses affect, and make sure that you can get on that chart and be I think it's a grade 1, grade 1 material. And then you're going to be specifying your heat treat, okay, according to that chart. Normally the contact stress is the one that dictates the design, but I want you to use 3 hardened materials. Don't go to the other charts. Don't go to case hardened. Don't go to other fancy materials. We're just using regular steel gears here, okay? Any questions kind of on this? Again, cruise director overview. Okay, so you're going to do two of these. One for the first reduction, and then on the input for the second reduction, this is going to be your speed from the output from the first reduction. Okay, And then you're going to go through that same process and pick gears, have your Browning catalog pages either available or I got printouts here in the room. Okay. Now, once you've done that process, okay, then what you're going to do is you're going to add a tab down here and do that design review and add the vendor numbers, your vendor, you know, all the information that I was asking for in the list on the assignment for the gear design. Okay. And you want to have that for potentially all 4 gears. Okay. If you have 4 different parts or 4 different gears that you're calling out, then you want to have that information for each one of the gears. And again, I'm referring to in the assignment, these items right here. The last 4 you won't be filling in, but the first ones without the asterisk, you will be able to give me from the information that you have here. Okay. So that's gear design. Any questions? Yeah.
In general, gears be the same diametrical pitch in a gear frame like this?
They do not. No, the only ones that have to be the same diametral pitch are the 2 that are engagement. So you could have a totally different diametral pitch for your first reduction as you do for the second. Absolutely. And that happens because as you push through, what increases? Torque increases, right? And the more torque that you have that you're pushing through, that second reduction is going to see higher stresses. Mm-hmm. Yeah. But sometimes you can get away with the same set. I'm not saying that you can't, and some students really try to make that happen, and that's okay, but it's not a requirement. It's not a requirement. Mm-hmm. Other questions that you have? All right. So then that's your overview for the gear design. Okay, so I'm going to stop recording.